Hello everyone, I'm back. My name is Zazibiela from Entertainment, reminding you that enthusiasm implies excellent. We are still working with calculus, but the problem that you are faced with today, we are required to determine the derivative of f at x is equal to 2x squared plus 4 from first principle. Okay, if you are told that you should work with first principle, that's why you have to use this formula. F prime x is equal to a limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, in this scenario we know f at x, but we don't know f at x plus h. So the first thing to do is to find f at x plus h. Okay, how do we find f at x plus h? We find f at x plus h by using this equation. F at x is equal to 2x squared plus 4. But the difference is when I see x, I will plug x plus h. So here it will be 2. Instead of x, I plug x plus h. You square it plus 4. Okay? This can be written as, you can open a square bracket, all right, x plus h plus 4. Okay, from here you see that you can write 2, so x times x, it becomes x squared, x plus times h becomes plus xh, h times x, it becomes plus xh, and h times x becomes h squared. You add 4. Okay, so here you have 2, you have x squared, you add these like terms, you end up with 2x h plus h squared plus 4. Okay, so from here you can distribute 2 throughout, you end up with 2x squared plus 4x h plus 2h squared. Don't forget this 4 plus 4. Okay, now you know f at x plus h. You can take this and go back to the equation that was given to you. Okay, it says that a limit as h approaches 0, f of x plus h minus of x all over h. Okay, now you know your f at x plus h. So meaning instead of f at x plus h, you will write this, of which is 2x squared plus 4xh plus 2h squared plus 4 minus, okay, in this scenario we have f at x being equal to 2x squared plus 4, meaning we have to open the bracket and write 2x squared plus 4. Okay, and then from there this is all over. It's all over what? It's all over h. Okay, So a limit as h approaches 0 of 2x squared plus 4xh plus 2h squared plus 4 minus 2x squared minus 4 all over h. Okay, from here you see the like terms. Okay, you can see 2x squared and 2x squared cancels, 4 and minus 4 cancel, so you are left with what? You are now left with a limit as h approaches 0, 4xh plus 2h squared. You divide this by h. So from here, you can factor out h. It's a limit as h approaches 0. If you take h as a common factor, you are left with 4x plus 2h all over h. Okay, right? So from here, okay, from here when these two cancels, this one and this one cancels, you are left with a limit as h approaches 0 of 4x plus 2h. Ne? So you can now write, you now let your h be equal to 0. So you can write 4x plus 2. Instead of h, you plug 0. So you now left with 4x. All right. So this is the solution for, this is the solution of f prime f from the first principle of this f at x. Moving forward, so here we are required to determine f prime x using first principle if f at x is equal to 1 over x. How do we solve this one? Okay, again, we know that when they say first principle, this is what we are using. We have to derive x using this formula as h approaches 0, f of x plus h minus f of x all over h. Okay, over h. So you do know f at x, but you don't know f at x plus h. So the first thing to do is to find f at x plus h. Okay, use the very same approach as the one I specified previously, that where you see x, you replace it with x plus h. So f at x plus h is equal to 1 over x plus h. Okay, meaning when we have to find a limit, okay, f prime of x, of which is a limit as h approaches 0, f at x plus h can be written as 1 over x plus h minus 1 over x. Remember, this is all over what? All over h. Okay? All right. Okay. From here, On the numerator part, we can find the common factor of a numerator part, since a numerator is also a fraction. So a limit as h approaches 0, here you can take x and x plus h as a common factor, or as a LCD, sorry, all over. So this one that becomes ax, because this one goes to this one and leave this one, and this one times 1 becomes x, minus x goes to this one and leave this one, so this becomes x plus h. All of this thing is being divided by h. Okay, from here this is equal to a limit as h approaches 0. H approaches 0. Okay, here you see that x and this it's minus 1 times x becomes minus x, minus 1 times h becomes minus h. You divide this by x, x times x squared, x times h is xh. Okay, let us do this. Let me write division on this side. I divide by h. Okay, of which is something that I can write it like this. Okay, here I have x. Okay, wait. If you can look carefully here, this one and this one cancels. I'm left with minus h over what? Over x squared plus xh, and I multiply this with 1 over h. So if you are dividing by h and multiplying by 1 over h is one and the same thing. The only thing that I did is to change the sign into this sign. So when I multiply, I'll be multiplying by 1 over h, because while I was dividing, I was dividing by h. Okay, so if you can look carefully here, this one and this one cancels. I'm now left with a limit as h approaches 0. Here it was minus 1. That means it becomes minus 1 over x squared plus xh. So now I can let my h be equal to 0. Okay, by so doing, by letting my h to be equal to 0, that means I won't have to continue writing this now. I have to bring back this. Where I see h, I replace it with what? With 0. It's plus x and multiply x by 0, because now my h is 0. So it becomes minus 1 over x squared. That is the differentiation of x using first principle. I hope this video was helpful to those who are doing grade 12. I'm looking forward to meet you in my next video. Thank you.